Priyanka. Today we are going to solve a problem on stability analysis and root locus technique. In this video we are going to apply Routh Hurwitz criterion to determine the stability of a system. Here we will take the case when the 0 appears in the first column. Let us first observe what is the characteristic equation for a given system. 1s raised to 5 plus 2s raised to 4 plus 3s cube plus 6s square plus 5s plus 3. So what is the first step? So first step is the formation of Routh array. So for the formation of Routh array, we have to take here one vertical line and we have to plot here some numbers. That is, here this is the higher order equation. Now if we observe, we have to take here first number, that is s raised to 5. Then next is s raised to 4, s raised to 3, s square, s and s raised to 0. Now for the formation of Routh array, we have to complete the first two rows. So first two rows in front of s raised to 5. So this is the first row and second row is s raised to 4. So how to select the numbers? So these numbers are nothing but the coefficients in this given equation. So first row coefficient. So how to select the coefficients for the first row? So for that we have to select the first digit. So first number is s raised to 5. Then we have to take alternate, that is 3s cube. Then alternate is 5s. So I have written here with the help of black marker 1s raised to 5, 3s cube plus 5s. So these are the coefficients 1, 3, 5. So we will plot here 1, 3, 5. Then how to select the numbers for the second row? So for that again we have to take for second row, we will select here the second number. So second number is 2s raised to 4. So what is the coefficient? That is 2. Then next is 6s square and 3. So we have to take 2, 6, 3. Here is 2, 6, 3. Now next row that we have to complete by calculation. So we will calculate with the help of these first two rows. Now I will mark here with the help of arrow 2 multiplied by 3 minus 6 multiplied by 1 divided by 2. So I will write here 2 multiplied by 3 minus 6 into 1, 6 and divided by 2. So here 6 minus 6, that is 0, and 0 divided by number 2, that is equal to 0. So here 0 appears in the first column. Now we will move for the next calculation. So for next calculation we have to take 2 multiplied by 5. So I will show with arrow. Minus 3 multiplied by 1 divided by 2. So I will write here 2 multiplied by 5 minus 3 multiplied by 1, that is we will take 3 and divided by 2. So 2 into 5, that is 10 minus 3. So 10 minus 3, that is 7, and 7 divided by 2. So here second number is 7 by 2 and third there is no any, we have to take here, that is 0. So this first column number is important. So for the first column number, if we observe, there is 1, 2 and then here is 0. So for this 0, how to take the next procedure? So it is very important. So when 0 is there, we will select instead of 0 number epsilon. And epsilon is very small number, that is it is slightly greater than 0. So we can say that this epsilon is in between, 0 is less than, epsilon is less than 1. That is epsilon is very small number. And when we take instead of 0, that is epsilon, then again we are going to calculate for the next row. So I will rearrange the two rows. So we have to select for a calculation for s square rows, we have to select the numbers from s raised to 4 and s raised to 3. So I will rewrite this 2, 6, 3. So I will rewrite here 2, 6, 3, and here instead of 0 I will take epsilon 7 by 2. Now here we have to take 0. Again with the help of arrow I will show this. Epsilon multiplied by 6 minus 7 by 2 multiplied by 2 divided by epsilon. So I will write here epsilon multiplied by 6, I will take 6 epsilon. So 6 epsilon minus 7 by 2 into 2, that is minus 7 divided by epsilon. So this calculation is getting completed. Now we will move for the next. So next again I will show with the help of arrow. Epsilon multiplied by 3 minus 0 multiplied by 2 divided by epsilon. So I will rewrite here 3 epsilon. Epsilon multiplied by 3, that is 3 epsilon minus 0 multiplied by 2, that is 0. So I will not write that, divided by epsilon. So here only which is equal to 3. Then here next number there is no any digit, so I will take here as a 0. Now we will move for the next calculation. So how to calculate next? So again for the calculation for the number of rows in the for this S in front of S, we have to take the above 2 rows. So again I will rewrite these numbers. So what are those numbers? That is, instead of 0 we have to take epsilon. Then epsilon, here is 7 by 2. Then we have to take 6 epsilon minus 7 divided by epsilon, and here we have to take 3. And next we will take 0. So only one calculation is there. So I will show this calculation with the help of arrow. Now I will rewrite here. So 6 epsilon minus 7 divided by epsilon. 6 epsilon minus 7 divided by epsilon, bracket complete multiplied by 7 by 2 minus 3 multiplied by epsilon, that is minus 3 epsilon divided by, again we have to take this, that is 6 epsilon minus 7 divided by epsilon. Now we have to simplify this. So how to simplify this? So we will first solve numerator and then we will take the denominator. So I will take first, I will multiply here with 7 inside and these 2 inside the bracket. So here I will take 7 multiplied by 6, that is 42 epsilon minus 49 divided by 2 epsilon minus here 3 epsilon. Then I will simplify this. So for this 3 epsilon also I will take denominator as a 2 epsilon. So we have to multiply this 2 epsilon with numerator and denominator. So I will take here. So I will simplify here. 42 epsilon minus 49 minus 3 epsilon multiplied by 2 epsilon, that is 6 epsilon square divided by 4 divided by 2 epsilon divided by here 6 epsilon minus 7 divided by epsilon. So this epsilon from denominator is getting cancelled. Now I will take this term to the, I will again simplify this. So I will take here 42 epsilon minus 49 minus 6 epsilon square divided by 2, and this epsilon is getting cancelled. Now so here in the denominator it is become 6 epsilon minus 7. So if I multiply with these 2 inside the bracket, then I have to write 12 epsilon minus 14. So I will write here directly, that is 12 epsilon minus 14. So this is the simplified form and we have to write. So instead of this calculation I will rewrite directly, that is, so I will remove this all this and I will directly write this answer because this answer is important. 42 epsilon minus 49 minus 6 epsilon square divided by 12 epsilon minus 14, and here the next term is 0 because here only one calculation is there. Now for the calculation of s raised to 0, again we have to select the above 2 rows. So again I will rewrite this. So if we observe, here is only number 3 and minus suppose we have to multiply this for this whole equation with 3 and minus 6 epsilon minus 7 divided by epsilon multiplied by 0. So this whole term will become 0 and again we have to divide this equation by this equation. So if we calculate this, then this equation from numerator, and again we have to divide the same equation in denominator. So this is getting cancelled and only 3 remains there. So here I will write here directly, that is 3. Now we will apply Routh Hurwitz criterion to determine the stability. So for that we have to first determine the number of sign changes in the first column. So we will take here the condition when epsilon tends to 0. So when epsilon tends to 0, what are the values in the first column that we determine first? So I will write here these values, that is s raised to 5, s raised to 4, s cube, s square, s and s raised to 0. So what are the values in the first column? That is 1, 2. Now here epsilon, but epsilon tends to 0, that is the condition, so I will write here 0. Then here if I put epsilon is equal to 0, then what is this value? That is minus 7 divided by 0, and that is nothing but minus infinity. So I will write here minus infinity. Then if I write here epsilon tends to 0, that is epsilon is equal to 0, then what is the value here? That is minus 49 divided by minus 14, that is I will write 49 divided by 14, and here is 3. Now we have to determine the changes in sign. So I will write here the next column is for sign. So here first value is plus sign, then plus sign. Here for 0 it is plus sign, then infinity is having minus sign, plus sign and plus sign. Now how many number of changes in sign? So I will show here from plus to minus, that is change in sign. So this is the first sign change. And then again from minus to plus. So here is second change in sign. So I will say second sign change. So number of sign changes, that is equal to 2. So I will write here number of sign changes, that is equal to 2. So from that we can say that the number of poles in right half plane. So how many number of poles? That is equal to number of sign changes, that is equal to 2. Now we will understand what is this right half plane. So we know that S plane is nothing but it is the combination of real axis and imaginary axis. So I will show that. So this real axis is known as sigma, and this vertical axis is nothing but imaginary axis, and that is j omega. So this plane we will consider as a S plane. Now if I give here the number to the quadrants, that this is the first quadrant, second quadrant, third quadrant and fourth quadrant. Then according to this number of poles in the right half plane. So this first quadrant and fourth quadrant is nothing but right half plane. So I will say right hand side, that is right, these two planes, these two quadrants are nothing but the right hand sides of this S plane, and these two, that is second and third quadrant, is the left half plane. So we know the rule, when the poles appears in these two right half plane, then system is unstable. So according to this Routh criterion or Routh Hurwitz criterion, number of changes in sign, that is equal to 2, and that is why number of poles in this right half plane, that is equal to 2, and we can say that the system is unstable.